Welcome to today's deep dive. We're getting into a really fascinating piece of tech narrative today.
Yeah, it's definitely not your typical dry technical white paper.
No, not at all. It's a blog post from tech-reader.blog, published on May 6, 2026. It's written by Aaron Rose, and it's called The Secret Life of AWS, What S3 Really Does.
And the way he frames this is just brilliant.
Right. Our mission today is basically to shatter this assumption that Amazon S3 is just some profoundly boring, passive digital filing cabinet. We want to show you how it's actually the secret, highly active engine that runs modern software architecture.
Exactly. And Rose does this by writing a fictionalized dialogue. He sets it inside this grand Victorian library in London, which gives it this really cool, almost cinematic vibe.
It totally does.
We follow Margaret, who's this formidable senior software engineer, and her junior colleague, Timothy. And Timothy arrives at the library with his notebook, fully expecting a basic, totally standard lesson on where to store files.
Which, reflects the default mindset of practically everyone in the industry. Okay, let's unpack this. Let's look at what Timothy actually believes at the start of the story, because I think it's universally relatable.
Oh, 100%.
If you ask any developer how they use S3, you get the exact same lists Timothy gives Margaret, right? Application assets, configuration files, maybe daily backups.
Yeah, he basically calls it a place where you put things so they exist.
Right, like if you need an image to live on the internet, you just drop it in a bucket and completely forget about it.
And Margaret immediately calls that mindset out.
Yeah.
She straight up labels it passive storage.
Which is such a great term for it.
It is. And, she acknowledges that passive storage is a valid way to use S3, sure.
Yeah.
But she argues that treating it merely as a destination is a total failure of imagination.
Yes, and that sets the analytical tone right from the jump.
It really introduces her core thesis, which is that S3 is a design decision. It's not just infrastructure. Choosing how you use a bucket fundamentally dictates the capabilities of literally everything you build downstream.
So to understand how a storage bucket shifts from passive to active, we have to look at what happens the exact millisecond a file arrives.
Right, the very first moment.
Exactly. We need to talk about event notifications, because the traditional expectation is that you upload a file, the hard drive spins, the data is written, and the transaction is basically over.
Yeah, a very linear dead-end process.
But under the hood, S3 has this total instantaneous awareness of its own state. It's basically a highly sensitive tripwire.
It really is. It knows the exact moment an object is created via a PUT request. It knows when an object is deleted or when an archive is restored from deep, cold storage like AWS Glacier.
But by default, it keeps that awareness to itself, right?
Yeah, right. But if you configure it to do so, S3 will actively broadcast an alert the very millisecond any of those state changes happen. It generates this detailed JSON payload containing all the metadata of the file, and it just fires it off.
And it isn't just firing those alerts into the void. AWS actually routes that signal to other active services.
Exactly. The text highlights a few very specific targets.
Like AWS Lambda, right?
Yeah, Lambda, which runs serverless code. Or it can send a message to an SQS queue.
And an SQS queue is basically like a waiting room for background tasks, so your main app doesn't freeze up while it's processing data.
Perfect way to describe it. Or S3 can broadcast to an SNS topic. That acts like a megaphone, basically notifying dozens of different microservices simultaneously that a new file has arrived.
And the examples Margaret walks Timothy through really ground this concept.
They do. Like, imagine a user uploads a high-resolution profile picture. The arrival of that image in the S3 bucket instantly triggers a Lambda function. That function spins up a container, resizes the image into a tiny thumbnail, saves that thumbnail back to S3, and spins down.
All in the background.
Exactly. Or think about a massive CSV file full of sales data just being dropped into a bucket.
That drop triggers a pipeline that validates the rows, right?
Yeah, validates it, transforms the data formats, and loads it directly into a live database.
Okay, but I have to push back here for a second. Doesn't an event-driven pipeline like that just push the server management problem somewhere else?
How do you mean?
Well, doesn't something somewhere still have to be watching? Like some server has to sit there continuously asking the bucket, hey, do you have new files? How about now? How about now?
And that is the exact crucial paradigm shift Margaret is trying to teach Timothy.
Okay.
There is absolutely no server polling the bucket. The event mechanism is entirely self-contained within the AWS control plane.
Oh, wow. So there's no intermediate listener.
Exactly. The arrival of the data itself is the catalyst for the computation. Think about it this way. If no files arrive in your bucket for an entire month, Zero compute resources are used. You pay literally nothing for idle servers.
Because there are no servers waiting.
Right. But if, say, 10,000 files arrive in a single second, the S3 event bus instantly fires 10,000 independent notifications to process them all in parallel.
That's incredible.
Margaret has this great quote. She says, S3 is the mouth of the river, not the lake at the end.
The mouth of the river, that makes so much sense because the data enters there and then flows downstream, triggering everything else.
Which is exactly why the bucket's configuration is a foundational architectural decision.
And that leads to a much bigger question. If S3 can trigger all these complex workflows entirely on its own, without an active server pulling it, do we actually need traditional web servers at all?
You're jumping to the exact realization Margaret pushes Timothy toward, the concept of the server that isn't there.
Here's where it gets really interesting.
It really does. Because for decades, if you wanted to serve a website, you had to run server software. Apache, Nginx, Microsoft ISIN, whatever.
Right, you had to provision a machine, configure the routing, patch the operating system.
Monitor the memory usage so it doesn't crash. All of it. But Margaret points out that S3 can host a complete website entirely on its own.
Just directly to the browser over HTTP.
Exactly. You just upload your raw HTML, CSS, and JavaScript files to the bucket. You toggle a simple setting called static website hosting, specify your index document, and AWS just hands you a URL.
And the browser requests the assets directly from the storage layer. It completely bypasses any back-end routing.
Right. And when you pair that storage bucket with CloudFront, which is Amazon's global content delivery network, it fundamentally alters the physics of web traffic.
Because CloudFront adds that layer of edge caching.
Yes. It takes the files sitting in your S3 bucket in, say, Virginia, and copies them to server nodes located in hundreds of cities all around the world.
So if a user in Tokyo visits your site, they download the files from a node in Tokyo, not all the way from Virginia.
Exactly.
So if your site suddenly goes viral and you get hit with millions of requests, a traditional web server might literally catch on fire because its CPU just maxes out.
Oh, yeah. Total meltdown.
But an S3 bucket behind CloudFront essentially cannot be overwhelmed. You don't have to do any capacity planning at all.
And you achieve that massive scalability at a fraction of the cost of running a whole fleet of traditional servers. But, and this is important, Margaret is very careful to outline the hard limitation here.
Which is that S3 doesn't compute anything.
Right. It only serves static files.
But wait, if it can only serve static files, and it has no server-side logic, how is this actually a complete web application? Doesn't that just make it a glorified brochure? Like, how do you process a login or query a database?
And that right there brings us to how modern client-side applications actually work. When we say static hosting, we do not mean the website itself is just an unchanging dead document.
Okay, so what do we mean?
Margaret explains to Timothy that this is the ideal architecture for single-page applications.
Ah, like things built with React or Vue.
Exactly. React, Vue, Angular.
Oh.
S3 serves the raw JavaScript to the user's browser, and then the user's laptop or phone does the actual computing.
So the browser itself is compiling the interface on the fly.
Yes. The heavy lifting happens on the client side. And if that application needs dynamic data, say, it needs to fetch a user's bank balance or submit a shopping cart, the JavaScript running in the browser makes a direct API callback to a Lambda function.
Or an EC2 instance.
Right. The front-end delivery and the back-end logic are completely decoupled.
So S3 is strictly the delivery vehicle for the interface.
Yes. And Margaret notes that there is a deep psychological barrier that developers face here. She talks about how engineers literally have to unlearn the instinct to reach for a server.
Because serving a website has meant a server for basically the entire history of the internet.
Exactly. The idea of deploying a massive, complex enterprise application to a quote-unquote dumb storage bucket just feels wrong to a lot of people. It's a huge philosophical hurdle.
But once you cross that hurdle, if S3 can swallow entire web frontends without a server, its limitless capacity naturally leads to its most consequential role at scale, right?
Absolutely. It becomes the foundation of massive data lakes.
Yeah. Margaret introduces Timothy to the concept of S3 as the landing zone.
Because in modern enterprise systems, you have these absolute oceans of data coming in from so many diverse sources.
Right, like application logs detailing every single error.
Or clickstream data showing exactly where users are hovering their mice on a website.
You've got IoT sensor readings streaming in from factory machines, millions of financial transactions a day.
And historically, if you wanted to analyze all that data, you had to carefully extract it, transform it into a very specific format, and load it into a highly structured relational database.
You had to use what they call schema on write. And let's use an analogy for how painful that is.
Okay, let's hear it.
Schema on write is kind of like building rigid shelves in your closet before you even know what clothes you own. Or it's like forcing every single piece of data through a strict TSA security checkpoint before it can board the plane.
Oh, I like the TSA one.
Right. If the data doesn't fit the exact dimensions of the X-ray machine, it gets rejected and dropped. You have to know exactly what the data looks like before you save it.
Which is incredibly limiting, whereas the S3 data lake approach utilizes schema on read.
Right. Schema on read is basically S3 acting like a massive warehouse. It lets all the raw baggage out onto the tarmac in whatever shape it arrives in. JSON files, CSVs, raw text logs. S3 just doesn't care.
It just holds it.
Exactly. You only impose structure, you only inspect the baggage when you actually need to query it.
And that flexibility is precisely why S3 is the foundational layer. Because you might not know today what analytical questions your business is going to need to ask 3 years from now. By storing the raw, untampered data in S3, without forcing it into a strict database table, you preserve all its original detail. But, as the article points out, the raw storage is only half the story.
Because of the tools built on top of it.
Right. There's a whole suite of AWS services engineered specifically to sit directly on this S3 substrate.
The sheer scale of the ecosystem is pretty wild. The article mentions Amazon Athena, for instance.
Yeah, Athena is huge here.
It allows you to write standard SQL queries to analyze data while it is still sitting as raw text files in the S3 bucket. You don't have to load the data into a database first. Athena just treats the bucket itself as the database.
And then there's AWS Glue, which uses these automated crawlers that comb through your bucket, infer the schema of your messy data, and catalog it for you.
Not to mention Redshift for data warehousing and SageMaker for machine learning.
Right. SageMaker can train advanced machine learning models directly against the raw terabytes stored in those buckets. So S3 is not just one tool among many in this analytics stack. It is literally the earth that the other tools are built upon.
But wait, doesn't this schema on read flexibility inevitably create a massive, unorganized digital junk drawer?
That is the big fear, yes.
Because if you are just dumping raw server logs, sensor readings, and financial records into a bucket without any rigid rules, how can a tool like Athena possibly make sense of it efficiently?
If we connect this to the bigger picture, Margaret actually issues a really stern warning to Timothy about this exact risk. The lack of rigid database tables does not mean a lack of design.
Okay, so you still have to organize it.
Absolutely. She emphasizes that if the S3 architecture is fundamentally flawed, every single tool built on top of it just inherits that flaw.
So if you just dump a billion log files into the root of a bucket and you ask Athena to find an error from last Tuesday,
Athena's going to have to scan every single one of those billion files to find your answer.
yikes.
And because Athena charges you based on the amount of data it scans, a poorly organized bucket will result in a massive, totally unnecessary bill.
So it's not just a performance issue, it's a financial one.
Exactly. Margaret explains that you must design a smart partition strategy. You organize the data into a hierarchical folder structure by year, then month, then day. This allows Athena to ignore 99% of the bucket and only scan the folder for last Tuesday.
I love this quote from Margaret. In AWS, configuration is architecture.
It's so true.
Choosing a folder structure or naming convention isn't just some minor administrative task. It dictates the speed and the cost of your entire machine learning pipeline down the road.
Which leads perfectly into the climax of Aaron Rose's narrative.
Yes, the psychological trap.
Right. Because S3 is so flexible, because it integrates so seamlessly into event pipelines and serverless front ends and massive data lakes, it creates this really dangerous situation. Margaret calls it the load-bearing realization.
I think this might be the most important concept in the entire article. It describes this phenomenon where a bucket's importance silently drifts over time. Let's look at how this actually happens in the real world. Imagine a startup team building a new app. They need a place to put some background storage, maybe just company logos, or a few temporary backup files. So they spin up an S3 bucket.
Very standard.
Right, and it's totally secondary. If that bucket disappeared, the main app would still run perfectly fine.
But as the company grows, the engineering team realizes how cheap and frictionless S3 is to use. So they start adding features.
They realize they can save money by moving the React front end over to the bucket.
Yep. Then someone sets up an event notification so that whenever a user uploads a document, S3 triggers the processing pipeline.
And later, the data science team decides this bucket is a really convenient landing zone for the daily analytics dump.
So this accumulation happens gradually, totally, without any grand architectural review.
Yeah.
And then, one random Tuesday, the team looks at their infrastructure and realizes that this simple little storage bucket is entirely in the critical path.
The application interface literally won't load without it. The automated processing pipeline is dead without it.
The data lake is starved without it. It has become a load-bearing pillar of the entire business.
It became load-bearing not by conscious design, but simply by accumulation.
And convenience.
Exactly. So what does this all mean? If Amazon S3 is as bulletproof as the article claims, offering, 11 nines of durability? Why is this silent accumulation actually a bad thing? If the service doesn't crash, who cares if it's load-bearing?
Because there is a vast difference between the reliability of the AWS infrastructure and the operational readiness of human beings.
Human error.
Always. S3 itself will not go down. But human error is a constant. When a bucket drifts into a critical role unnoticed, it is almost always still configured like a passive, unimportant repository.
Oh, wow. So it still has the default settings from the day it was created to hold those company logos.
Precisely. It likely has highly permissive access controls, meaning any junior developer in the company could accidentally modify it.
Right.
It probably doesn't have object versioning enabled. So someone runs a bad script and accidentally deletes the production front-end assets.
Or overwrites the analytics data.
Exactly. It is permanently destroyed. There are no lifecycle policies to move old data to cheaper storage, so costs just quietly spiral out of control.
It's the equivalent of realizing the central support beam holding up your entire house is actually just a piece of balsa wood that someone wedged in there as a temporary fix 5 years ago.
That is a terrifying but very accurate analogy. And Margaret delivers the ultimate lesson to Timothy here. She says, a service that is load-bearing must be treated as load-bearing.
Meaning you have to actually secure it.
Yes. If a bucket is running your front end and your data pipelines, it requires the exact same rigorous security reviews, strict access policies, and disaster recovery planning as your primary production database.
So the overarching philosophy really boils down to this: intentionality over convenience, design over default.
Design over default, I love that. S3's simplicity is its greatest feature, but clearly also its greatest danger.
Because it doesn't demand attention, it is incredibly easy to underestimate. And when a failure does inevitably happen, when permissions get tangled up or a critical file is deleted, that quiet bucket suddenly becomes the single most important thing in the room.
The blast radius of human error just expands exponentially when we fail to recognize the invisible critical paths in our systems.
And, that concept extends so far beyond just cloud architecture.
Oh, definitely.
Whether you are a software engineer managing petabytes of data, a project manager setting up workflows, or honestly just someone trying to organize your digital life, understanding the difference between passive storage and active infrastructure is how you prevent total disaster.
Aaron Rose leaves the reader with a fantastic teaser for the next chapter of Margaret and Timothy's conversation, too.
He does. The narrative hints that they're going to move on to discuss AWS Lambda and serverless compute.
And Margaret poses this really provocative question to Timothy. She asks, if you can remove the server from the equation entirely, why would you ever put it back?
Man, that really forces you to justify every single piece of complexity you add to a system.
It does.
So we want to leave you with a thought inspired by Margaret's rigorous questioning. Take a step back and look at your own daily life, your team's workflows, or your business operations.
Yeah, what's your version of the bucket?
Exactly. What quiet, simple tool or process have you treated as a passive convenience that has secretly become load-bearing?
Maybe it's a messy Excel spreadsheet that tracks all your client invoices.
Or a shared Google Drive folder that entire departments rely on, but absolutely no one actually backs up.
Or maybe it's just a casual weekly meeting that is literally the only place actual decisions get made.
If that tool or process vanished tomorrow, would things collapse? Did you consciously design it to be that critical, or did it just sort of accumulate over time?
Applying design over default to those invisible pillars is how you reclaim control of your systems.
Absolutely. So the next time you drop a file into a digital filing cabinet, remember you might actually be standing at the mouth of the river. Thanks for joining us on this deep dive. We'll see you next time.